Hello, this is Martin McCabe, and this is my screencast for Client-Server Distributed Programming CA1. The problem that we were presented with was to create a messaging service that would allow for the following. Compose and send messages to one or more users. To fulfill this problem, we created a multi-user chat system and also a private message system that sends messages to a single user. Receive and read messages from the time of your last login. The messages you receive here are any private messages that have been sent to you when you were either online or offline. Methodology. The way in which we went about creating the chat system is as follows. I created the GUI and most of the client functionality, and my partner Brian created the database and server functionality, but we each done other work on either the client or the server. Other than implement the GUI, I also sorted the users into online and offline users and sorted the private messages based on the user. I also done some testing on the client and GUI. Design. I designed my GUI based on some early sketches I made when Brian and I were going through the problem definition and deciding on how we can implement a solution. I wanted to have all the functionality in one window, so I decided to use tabs to separate out all the different parts. When you launch the client, you are presented with a connect screen and a text field that allows a user to specify the server IP address. Once you connect to the server, you must either log in or register. You are unable to select any of the other tabs. The chat tab holds a multi-user chat system. It works like an IRC client where all online users are able to see what other users have typed. Within the inbox tab, there are two further nested tabs. The read tab is where the currently logged in user can read any private messages that have been sent to them. The chat tab is where the user can send a private message to another user. The details tab is where the user can choose to either change their username or password, and to log out all the user has to do is close the window. The UML diagram was too large to put on one screen, so I split it into 5. To implement the GUI, I created it within the client class. An instance of the client is created in its main class. When the user clicks on the connect button, its action listener calls the action performed method. In here I pass the IP address from the text field to the run method that holds all the connection functionality. To stop the application continuing on even if it is unable to find the server, the run method returns a boolean. True if it connects, false otherwise. I then swap out the connect panel for the tabbed panel. Here you can see the SQL statement that returns all the users from the database. It then puts those users into user list. Here you can see the users getting sorted into online and offline users. Client list holds the users that are currently connected to the server, where user list holds all the users. We saw user list get populated in this last slide. Once both lists are populated, I remove any users from offline lists that appear in client list, so that offline list only holds the offline users. You will see how I achieve this in the next step. After the lists are ready, we send them to every user of client list, in other words, all the online users. Here you can see how I remove any users that appear in two separate lists by using a nested for loop. In this slide you can see the ArrayList temp getting populated with private messages and then sent over to the client. What's interesting here is that the database only returns the private messages that were meant for the logged in user. This is achieved in the SQL statement where you see the target is equal to username. Here username is the name of the logged in user. Here you can see the client receiving the array of private messages and the arrays of online and offline users. Because I've done all the sorting on the server, all I have to do here is clear the existing list models and then re-add the new information to them. This will then automatically update the JLists on the GUI. When a user clicks on a name in a JList, its list selection listener calls the value change method. In here I sort the private messages we received in the last slide based on the name the user selected. Firstly, I clear any existing messages from the list and then set the text in the display area to be cleared. Then, if the user selected an online user, we clear any previous selection in an offline list. Finally, we iterate through the array of private messages using a for loop, adding any message with the sender's name is the same as the name we selected to the message list. This slide is the same as the previous slide, the only difference being that a user has selected someone from the offline list. In this case, all we do is clear the online user list. The rest is the same. In this slide, all I'm doing is setting the text in the display area to be the same as the message that the user has selected in the message list. Here you can see the tests that were carried out to ensure the program wouldn't continue unless the user provided the correct information. Here you can see the chat dialog getting updated when the user logs on or sends a message. Here you can see the program displaying the messages that were sent to the selected user. You can also see how a private message is sent to a selected user. Finally, here you can see the updated received messages with the newly received private message. Another problem I noticed when I was testing was that the JList sometimes wouldn't update properly and they would become completely cleared. What I found weird was this only happened on some occasions and would fix itself as well whenever a user sent a private message or another user happened to log in. I'm not really sure why this happens. It could be to do with how I'm clearing the users before they get sorted into online and offline, or it could be to do with an update call not being correctly received.